Okay, let's talk about one of the most complex machines ever built by humankind, the modern aircraft carrier. I mean, this thing is a total paradox. It's a 100,000-ton floating city that's also a high-performance airfield, and it does all this in the middle of the ocean. So how does this insane fusion of steel and strategy actually work? Well, let's pull back the curtain on the incredible engineering that makes it all possible. You see, it all boils down to solving a series of physics problems that, on the surface, just seem completely impossible. And the most famous one is this. How in the world do you land a multi-million-dollar jet, screaming in at over 150 miles an hour, onto a target that's not only tiny, but also moving, without it all ending in total disaster? So just to give you an idea of the scale we're talking about, a commercial pilot has almost 2 miles of solid concrete to work with. A Navy pilot? Well, they get less than the length of a football field to bring a 30-ton aircraft to a dead stop. This isn't just difficult. On paper, it looks flat out impossible. To understand how they pull it off, we have to step onto what's known as the most dangerous 4 acres on Earth, the flight deck. This place is a world of controlled violence, where takeoffs and landings happen in just a matter of seconds. But before you can even think about landing, you have to take off, and that, right there, is its own incredible challenge. A fully loaded F/A-18 Super Hornet weighs around 66,000 pounds. To get airborne, it needs to hit 165 miles per hour, and it has to do it in just a couple hundred feet. The sheer power needed for that is just staggering. You see, you can't just use the jet's engines. They're not nearly powerful enough on their own to do the job that quickly. The solution is pure, unadulterated brute force, and it's buried right under the flight deck. It's the catapult system. It's basically a giant steam-powered slingshot that hooks onto the front of the aircraft and just hurls it off the deck with unbelievable acceleration. And the process itself, wow, it's this masterpiece of violent precision. The jet gets hooked up to a little shuttle on the catapult track. The pilot pushes the engines to full afterburner, so the jet is just straining against a holdback bar. Then, someone pushes a button. A torrent of high-pressure steam fires these massive pistons, and the jet is literally flung into the air. From the pilot's perspective, it's got to be one of the most intense experiences imaginable. So, launching is one thing, but like we said, the even bigger challenge is coming back. There's a reason a carrier landing is often described as a controlled crash, and it's a very, very good reason. So the answer to stopping a 30-ton jet is kind of the mirror opposite of the catapult, the arresting gear. We're talking about 4 incredibly strong steel cables, each about 1.5 inches thick, stretched tight across the landing area. The pilot isn't really aiming for a runway. They're aiming to snag one of these 4 wires with a tail hook on their jet. The approach requires superhuman precision. The pilot has to hit a moving target box that's only a few feet wide. And here's the crazy part. As soon as they touch down, they slam their engines to full power, not to slow down, but just in case they miss the wire and have to take off again immediately. If that hook catches, bam, the jet is slammed to a complete halt in about 2 seconds. It is an incredibly violent but incredibly effective stop. But the organized chaos you see on the flight deck, that's only half the story. Right below this 2-second airfield lies an entirely different world where another massive logistical puzzle is constantly being solved. You know, a carrier is home to an entire air wing. That can be over 75 aircraft, fighters, helicopters, surveillance planes, the whole shebang. You can't just park them all on the flight deck. There's no room. So where do they all go? The answer is the hangar deck, a colossal cavernous space deep inside the ship. And this isn't just some parking garage. It's a floating, full-scale maintenance depot that's 3 football fields long and can hold over 60 aircraft at once. It's down here that planes are refueled, rearmed, and repaired, all while being protected under the heavily armored flight deck. Okay, but how do you move a 30-ton fighter from this deep internal hangar all the way up to the flight deck? For that, you need the ship's heavy-lifting workhorses, 4 gigantic elevators built right onto the edge of the carrier. Each one is about the size of a house and is powerful enough to lift 2 jets at the same time, delivering them exactly where they need to be for the next mission. Now, powering the catapults, the elevators, and, oh yeah, moving a 100,000-ton ship through the water requires an almost unimaginable amount of energy. So let's go even deeper, to uncover the carrier's most closely guarded secret, its heartbeat. Just think about the fuel for a second. A conventionally powered ship of this size would burn through its fuel tanks in just a matter of days, maybe weeks. It would need a constant chain of tanker ships just to follow it around the world. But a carrier, It operates for decades without ever needing to pull into a gas station. How is that even possible? Well, the answer lies deep in the most protected part of the ship. And it's not a conventional engine burning fossil fuels. No, it's a controlled, self-sustaining nuclear reaction. That's right. Every single U.S. aircraft carrier is powered by two nuclear reactors, and this gives them their key strategic advantage, near unlimited range. They can sail at speeds over 30 knots for years and years, generating enough electricity to power a small city, all without ever needing to refuel. And the longevity of this power source is it's incredible. The nuclear fuel in those reactors lasts for approximately 25 years. I mean, think about that. A ship can be commissioned, serve half its life, and only then does it need to come in for its first refueling. That is an absolutely staggering feat of engineering. So, all this technology makes an aircraft carrier an incredibly powerful tool. But it also makes it a massive target. Which brings us to our final question. How is this floating city engineered to survive in a hostile world? The design philosophy here isn't about being invisible. I mean, let's be real, a 100,000-ton warship is pretty hard to hide. Instead, the entire ship is designed around a single principle, resilience. It is built from the keel up to absorb massive damage, whether from an enemy attack or a natural disaster, and just keep on operating. It's really a fortress of layered defenses. You've got key areas like those nuclear reactors and the command centers protected by layers of heavy armor. The entire hull is divided into thousands of watertight compartments, so if one area is breached by, say, a torpedo or a storm, the flooding can be contained. And you have damage control teams who are constantly training to fight fires and seal up hull breaches at a moment's notice. But at the end of the day, the most critical survival system isn't made of steel at all. If the ship is the hardware, the crew is the software that makes it all run. It takes nearly 6,000 sailors, pilots, engineers, and medics to operate this floating city 24/7. They're the ones launching the jets, running the reactors, and when disaster strikes, they are the ones who fight to save the ship. All of these systems, the catapults, the reactors, the armored hull, that crew of thousands, they all come together to create one of the most formidable machines on Earth. Its true scale, its complexity, and its power can really be summed up with one final mind-boggling number. Over $13 billion. That's the cost to build a single new Gerald R. Ford-class aircraft carrier. It's a number that represents so much more than just a ship. It's a nation's peak engineering capability, a floating piece of sovereign territory, and a concentration of power unlike anything else in the world. And that is the true secret behind the engineering of a modern aircraft carrier.